Hello and welcome to this video about how are stars distributed in space. And this video is almost like a bit of a history lesson, looking at how we know what the shape of the universe is and how we know how stars are spread out, and trying to look at some of the evidence and some of the arguments and some of the key players in coming to understand this situation. Okay, so starting on the small scale, here is planet Earth, and we were able to discover the size and sort of shape of our solar system. So as you can see, the Earth is tiny compared to the Sun, which itself is tiny compared to our solar system. And our nearest neighbour stars, which we can definitely measure using parallax, around us are light years away from us. Our nearest neighbour star is about, or I think it's this one, Alpha Centauri, which is 4.2 light years away. So this was the starting viewpoint, and what they wanted to do was to work out how all of the stars were actually distributed and is there a structure on a larger scale. So how are stars distributed? Well, if you have a look at this picture on the right hand side, this is a view of the sky, and it's taken with quite a long exposure setting, and so what I mean by that is lots and lots of light has been let in over a long amount of time, and it's using a telescope because they can see things here obviously that we can't see with the naked eye. I can see some dim things here, and this is a similar picture here, and in both cases we can see there's a huge dense area like a stripe up the sky where there's loads and loads and loads of stars, and I mean, out here at the sides is like stars dotted around. But the reason this sort of looks so bright in the middle is because there's actually thousands and thousands of stars all in a huge strip along here. Same in this. These brighter areas are just because there's so many stars packed into a relatively small space that, yeah, we've got this like strip of stars. And scientists looking at this observe that this is the same sort of across the sky in all directions, and they developed an idea that the way that stars are distributed in space is in like a big disk. This was a diagram that was drawn by hand by a scientist called Herschel in the late 1700s, and so this is what he thought the distribution of stars was in the universe. That this star in the middle here is our sun, and it's in some sort of disk, and this is like a two-dimensional shape, and these were spread out around us. So from this observation of the sky, that's what they thought. So a couple more pictures to help you know exactly what I mean here. So some sort of disk with the sun placed at some point in the disk, and they thought it had this huge swirling structure. And this is what it would look like from the side view, so like a planar shape, like a disk, and somewhere in the arms of that disk is the sun. Now this is not a photograph of the Milky Way, our galaxy. Sorry, this is what they called this. They called it the Milky Way. Why Milky? Well, because if you look up in the sky, you see this sort of milky white sort of section going across the sky. They called this the Milky Way, and this isn't a photograph, obviously, because if our sun's out here, you know, we can't travel to even our nearest next door neighbour star, let alone way outside of our galaxy. But yeah, this is the Milky Way, and this is what scientists understand about the shape of the stars distributed in space. And this view was long established, and yeah, up until the early 1900s, people were quite happy with this. And we thought that this was the universe, the Milky Way, this spiral thing, and this is the whole universe. But as we developed better telescopes, we started spotting strange things. This is a sort of thing that they saw, a zoomed in image on a section of sky, and not only do we have lots of stars, we've got this weird sort of cloud thing. And this cloud confused astronomers, and they didn't know what it was. And what they called them nebula, which comes from the Latin for star, or nebulae is the plural, and it comes from the Latin for clouds, not star. Because it looks like a cloud, but we didn't know, what is this? So some scientists thought they were clouds of gas and dust, but others thought that they contained stars themselves, so they were sort of clumps of stars. And they actually sparked quite a debate. Were they, close things? So if they were gas and dust, they'd be very, well, not very, they'd be close by, or they could be clumps of stars that are very, very distant. And this sort of became quite a division in the astronomical community. Half of the people thought that these nebula were gas and dust things that were quite close, and the other half thought they're very far away. And studying them, this idea that they were gas and dust became sort of less and less popular, because they did see what looked like star structures within these nebula. So this gas and dust close, it sort of kind of lost popularity, and we thought that they were sort of clusters or clumps of stars. And this, but people still thought they were close by. And this is an idea that was put forward for the shape of the universe, of everything, is that still we've got our central galaxy in the middle, but we've got some sort of astronomical stellar globules. And what they called these things was globular clusters. Globular sort of means like in a ball sort of shape. It's a bit like a blob. And they thought that these were sort of star clusters which were relatively close by. I say relatively close by. They measured some of these using Leavitt's technique. Whoa! And thought that they were around about 100,000 light years away. So it seems strange me saying that they thought that this was small and that they were close, but there were those who thought, well, actually these might be even further away. And it led to a moment in science known as the Great Debate. And it took place in 1920, and there were these two opposing views were put to the sword, and Curtis and Shapley were the leading voices of this. So we've got, firstly, Shapley's view. He believed in this image. This sums up quite nicely what Shapley believed, that the Milky Way is the universe, the only spiral nebula are found within it, and these nebula were other clusters and globules of stars. But Herbert Curtis, he thought that spiral nebula were actually distant island galaxies. So each of those nebula was a galaxy in its own right, very far outside of our galaxy, and that the universe was made up of loads of these. He thought the universe was enormous with loads and loads of galaxies, and Shapley thought it was our one galaxy with some little clusters around the outside. And these two came together to have this great debate in 1920, and obviously we don't have a recording or a record of that, but I've tried to recreate it for you here.
Yeah, well, my name is Curtis. I pre-rehearsed this. I'm gonna tell you all how big the universe is. It seems to me that these nebulae ain't even a part of our galaxy. What's that you say, Mr. Shapley? You think the universe is just the Milky Way? No, there are other galaxies out there. There are island universes and the cosmos we share. Well, my name is Shapley. Curtis, you be hated. Your idea's just been plucked from your imagination. These nebulae are just other groups of stars sharing the same galaxy as ours. Yeah, I'm Shapley. Yeah, and that's it. I'm out.
Now, as you will have heard from the performance there, Curtis was voted the winner of the the debate, because he argued his point better. He was a better debater. But there was a big problem with Curtis's idea, and Shapley alluded to it in that rap, that the data, the evidence Curtis didn't really have much data to support his view, and the current understanding was based on Cepheid variables that Leavitt had helped them to find, but they needed to get more data, and the breakthrough came when this chap here, Edwin Hubble, came on the scene in 1923, so it was a few years later, and he found within those nebula, he spent a long time very slowly and patiently photographing these nebula, and he found that they contained these Cepheid variables. And he used Leavitt's ideas, studied these Cepheid variables, and he was able to determine that these these nebula were actually even further away than we thought they were. And his data came back saying that they were 1 million light years away. And suddenly, sort of overnight, this completely changed the view of the universe. Curtis was declared the winner. So not only was he a better rapper, he actually had the correct idea. The universe is absolutely mind-bogglingly enormous, and it contains thousands of galaxies which are hundreds of or millions of light years apart. So this changes our view of how do we perceive the universe. And so how are stars distributed in space? Well, this diagram just shows here, this is our solar system here in the centre, and these are some of our nearest stars to us. This was all known before this great debate. We've got some which are 4, 5, 10 light years away, 20, 30 light years maybe going across the whole of this slide. Together they form the Milky Way, but we then start to see that there are other galaxies outside, and our nearest neighbouring galaxy is the Andromeda galaxy. And here, within this tiny little area here, is our local galactic group, so us, Andromeda, and some tiny other little mini areas. Then the one from that last slide, that Virgo supercluster of a few thousand galaxies, is here, and then this local supercluster is all contained within this space here. And the observable universe is billions of galaxies in all directions, and some of them, the furthest ones we see, are actually on the scale of billions of light years away. So the universe in our perception has just got massively bigger and bigger and bigger, and it's just crazy how big it is. It's too big for your tiny little brain. I'm not insulting you here. I'm talking about humans, all humans. My tiny little brain as well will never be able to comprehend how big it is. I can only just about comprehend that it's too big for me to comprehend. It's enormous. The universe is mental and it's massive, and it's through different scientists arguing, debating with each other, and using each other's work, doing research and coming up with new data and evidence that we were able to get this breakthrough.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
So to summarize, how are stars distributed in space? Well, we are part of a galaxy, and this galaxy, this idea has been known for about 100 years, but there is a mystery. What are these nebula? Are they close pockets of dust and gas? No, they're not dust and gas, they're stars, but they could still be close groups of stars. Or are they clumps of very distant stars really far away? This argument was settled, or not settled, it was debated at the Great Debate in 1920. Curtis had his opinion that they were distant galaxies, nebula distant galaxies, and Shapley had his opinion that they were clusters of close by stars. The debate, Curtis was the best debater and his idea was lauded, but then Hubble came along. He used Leavitt's idea of Cepheid variables. He found out that these nebulae, some of them were millions of light years away, and that led us to the idea that there were loads and loads of different galaxies, thousands and thousands of galaxies, spread across an enormous, incomprehensibly huge universe.